Hey guys, today we're going to expand a little bit on what we did with the power rule to those polynomial type functions where the exponent of x may be a rational exponent. Now, a rational exponent is when the exponent is written as a fraction. Now, this does not mean that you're going to do anything different. It just means that when we're applying the power rule, we may need to work with fractions. That means that you need to know how to add, subtract, and multiply these fractions. So let's start with this first one, where you have f of x is equal to 6x raised to the 2/3 plus 4x to the negative 2. As we learned with the power rule, to find the derivative, you take the exponent and you multiply it with the constant here, the coefficient. So 6 times 2/3. Now when you're multiplying 6 with 2/3, and we'll come back to this in a minute, and then it would be x and then 2/3, and remember we subtract 1. Then for the second part, this is what we've already learned. 4 times negative 2 is negative 8, x, and then subtract 1 from the exponent, which is negative 3. So now let's focus on this part here. 6 times 2/3, when you're multiplying fractions, you multiply numerator with numerator, denominator with denominator, which here the denominator is 1. So 6 times 2 is 12, over 1 times 3, which is 3. X. And now to be able to subtract 2/3 minus 1. This is like saying, I'm going to do it here off to the side, 2/3 minus 1 over 1. Now you need a common denominator, that's why I put the 1 over 1, which would be 3. So I'm going to multiply this denominator by 3, meaning the numerator also by 3. So this is going to be 2/3 minus 3 over 3. And now we subtract the numerators. 2 minus 3 is negative 1, and we keep the denominator of 3. And then again, minus 8x to the negative 3. And then finally, to just further simplify this, 12 over 3 is 4, x to the negative 1/3 minus 8, x to the negative 3. So this would be my answer for the derivative. Now, as a reminder, if I wanted to rewrite this using only positive exponents and without these rational exponents, 4x to the negative 1/3, that's the same as saying 4 over x to the positive 1/3 minus 8 over x to the positive 3. Now this rational exponent, remember that the numerator of the exponent is the power of x and the denominator is the root. So this is the same as saying 4 over the cube root of x to the first power, which is just x, minus 8 over x to the third. And that's just another way of rewriting it. Either one of these answers, they're all identical, so they're all acceptable. Moving on to the next one here. We're going to take this negative 1/2 and multiply it by negative 4. Negative 4 times negative 1/2 is positive 2, since this is the same thing as saying 4 divided by 2. X, and then we're going to subtract 1. As a little shortcut, what I do when I'm subtracting rational exponents, I mean, the same thing is going to happen every time. You're subtracting 1 and then you need a common denominator, etc., etc. So if you ever need to subtract 1, just look what the denominator is, which is 2. So I'm going to subtract 2 over 2. So negative 1 minus 2 is negative 3 over 2 plus, now 7 times 1/2. This is like saying 7 times 1/2. So 7 over 1. 7 times 1 is 7 over 1 times 2, which is 2. X. Here I'm going to subtract 1 from the exponent. So since the denominator is 2, I'm going to subtract 2 over 2, which would give me negative 1/2. So this would be our answer here. Now, depending on how you want to write your final answer, we can rewrite this using positive exponents. So this would be the same thing as saying as 2 over x to to the 3 over 2 plus 7 over 2x to the 1/2. Notice that I brought this x to the negative 1/2 down to the denominator, and since I already had a 2 in the denominator, I just attached it to the 2. So this is another acceptable answer. And if you wanted to write this using radicals, again, the numerator is the power of x and the denominator is the root. So this would be 2 over the square root of x to the third plus 7 over 2 square root of x. So this is another acceptable answer for that particular derivative. Let's try quite a few more. So here we have negative 8x to the negative 3/4 plus 2x to the 1/2. So we're going to multiply this negative 3/4 with negative 8, which again, if you just look at it, put it over 1, you're multiplying numerator with numerator. So that would be 8 times 3, which is 24, over 1 times 4, which is 4. And then we're going to subtract 1 from the exponent. Since the denominator is 4, I'm going to subtract 4 over 4. So negative 3 over 4 minus 4 over 4 is negative 7 over 4. Plus, now 2 times 1/2, again, you can put this over 1. 2 times 1 is 2 over another 2, so that would just be 1. I mean, and it makes sense, right? Because half of 2 is 1. X, and then I'm going to subtract 1. The denominator is 2, so this would be minus 2 over 2. So my new exponent would be negative 1/2. So this is my derivative. And I'm just going to keep practicing rewriting this using positive exponents and then rewriting it with the root. So 24 over 4, that's 6. Then x to the negative 7 over 4, I can bring this down to the denominator. So that would be x raised to the positive 7 over 4 plus, and x to the negative 1/2, that's going to move down. So in the numerator will just be 1 over x to the 1/2. So this is another acceptable answer. And if we write this using roots, this would be 6 over, now again, the denominator is the actual root, so this is the 4th root of x, and then the numerator is the power, so to the 7th, plus 1 over, and then 1/2 is always the square root of x. So when we have any root other than 2, we have to write that root as the index of the radical, whereas if it's a square root, you don't need to write the 2 here. So this would be your answer, or this one, or this one, once you simplify the 24 over 4. So either one of these are acceptable. Now for this next one, we have 3 over the cube root of x squared. In order for me to find the derivative of this, we would need to rewrite this in a polynomial type form, meaning I'm going to rewrite this using exponents rather than the root. So this is 3 over x, and again, power is the numerator, and the root is the denominator. And now I'm going to rewrite this by moving this up so I can use the power rule. So this would be 3x to the negative 2/3. Now I'm ready to find its derivative. So I'm going to multiply the exponent here with the 3. So again, this is over 1. 3 times negative 2 is negative 6 over 1 times 3, which is 3. X, and now I'm going to subtract 1. So I'm going to subtract, since the denominator is 3, 3 over 3. Negative 2 minus 3 is negative 5 over 3. Now let's rewrite this. Let's clean this up. Negative 6 divided by 3 is negative 2, x to the negative 5 over 3. Again, this is my derivative, but let's practice writing this with positive exponents and then with the radical. So f prime of x would also equal to negative 2 over x raised to the 5 over 3 And then if I write this with the root, this would be negative 2 over the cube root of x to the 5th. So again, either one of these are acceptable answers. For D, we have 3 times the square root of x minus 5x to the 2/3. Before I could take this derivative, we need to rewrite the radical using those rational exponents. So this is 3x to the 1/2 minus 5x to the 2/3. Now we're ready to find its derivative. So f prime of x is going to equal to 3 times 1/2. 3 times 1 is 3, over 1 times 2 is 2, x, and then I'm going to subtract 2 over 2, which would give me negative 1/2, minus, now we have 5 times 2/3, so numerator with numerator, that would be 10 over 1 times 3, which is 3, x, and now I'm going to subtract 1, so I'm subtracting 3 over 3. So 2/3 minus 3 over 3 is going to give me negative 1/3. So this would be my derivative. And again, just for other acceptable answers, this could also be written as 3 over 2x to the 1/2 minus 10 over 3x to the 1/3. And if we were to write this with roots, this would be 3 over 2 square root of x minus 10 over 3 cube root of x. For this last one here, we have 2x minus 3x squared over the 4th root of x to the 3rd. So let's start off by rewriting this using those rational exponents. So 2x minus 3x squared over x to the 3/4. Now, in order for me to be able to find its derivative, I need to combine these terms. I need to simplify this. So that means that we have 2x over x to the 3/4 minus 3x squared over x to the 3/4. So I split up my fraction so that I can simplify each individual term. Now remember, when you're dividing, we need to subtract those exponents. So let's rewrite these exponents so that it's easy to subtract. For 2x, the exponent is 1, so I would need to do 1 minus 3 over 4. Again, because I need to do 1 minus 3 over 4, I can rewrite 1 as 4 over 4 so that it has the same denominator. 3x squared, the 2 is over 1, so I need a common denominator, which for this would be 4. So I'm going to multiply 4 to both the numerator and the denominator. And this gives me a new exponent of 8 over 4. Now we're ready to rewrite this function. So we're going to do 2. 4 over 4 minus 3 over 4 would be x to the 1/4 minus 3x, and now we're going to do 8 over 4 minus 3 over 4, which is 5 over 4. So this is my function. Now we're ready to take that derivative. So f prime of x. 2 times 1/4 is 2 over 4 x, and now I'm going to subtract 4 over 4, which would be negative 3 over 4, minus 3 times 5 over 4. Again, if you just always remember putting it over 1 and then multiplying numerator, numerator, denominator with denominator. Negative 3 times 5 is negative 15 over 1 times 4, which is 4, x, and now I'm going to subtract 1. So this is 5 over 4, so I'm going to subtract by 4 over 4. 5 over 4 minus 4 over 4 is 1 over 4. So this is my derivative. But again, let's practice rewriting this using positive exponents. So this is going to equal to 2 over 4x to the 3/4 minus 15 over 4x to the 1/4. Now, if I want to write this with roots, this is going to be, oh, also, the 2 over 4 can be simplified to 1/2. So I'm going to make sure to simplify. If you can ever simplify your fractions, just make sure that you do so as good practice. So let's change this here. This is going to be a 1 and this is going to be a 2. And then same thing here. This is 1/2 and this is 1 over 2. Okay? So now let's rewrite this. This is 1 over 2. This is the 4th root of x to the 3rd minus 15 over 4, and this is the 4th root of x. And that's another way of finding your derivative. Now let's review once again how to find the equation of the tangent line when you're given some functions with these rational exponents or with trig. So let's try with this first one. We have f of x is equal to the cube root of x squared minus 2x when x is equal to 8. So the first thing that I'm going to need is my point of tangency, so f of 8. So we're going to plug that in. That would be the cube root of 8 squared minus 2 times 8. Now when you're trying to evaluate something like this, like the cube root of 8 squared, you can either square the 8 and then do the cube root, or you can do it the other way around by finding the cube root of 8 and then squaring it. I usually like to do the root first just because it'll keep your numbers smaller and easier to break down. So I'm going to rewrite this just so that it reflects that I'm doing it in that order. I'm going to do the cube root of 8 and then I'll square it minus 2 times 8, which is 16. Now the cube root of 8, if you have the cube root, that means that you're looking for 3 identical numbers that would multiply to give you 8. So you can still start this off like as if we're breaking down a square root, which is finding 2 numbers that multiply to give you 8. And those 2 numbers would be 4 and 2. Then I can further break down the 4 as 2 and 2. And see here we have 3 identical numbers that multiply to give me 8. So the cube root of 8 is going to equal to 2. Then I'm going to square it minus 16. 2 squared is 4, and 4 minus 16 is negative 12. So my point of tangency is 8, negative 12. So I'm going to hold on to this information. The next thing we need is to find the derivative of f of x in order to find my slope of tangency. However, I can't find the derivative when I have it written as a radical, so we're going to rewrite this using rational exponents. The cube root of x squared is the same thing as saying x raised to the 2/3 minus 2x. And now I can take that derivative. So f prime of x, 2/3 times 1 is 2/3 x, and now I'm going to subtract 3 over 3. So 2 over 3 minus 3 over 3 would be negative 1 over 3 minus 2. So this is my derivative. Now the reason why we were practicing rewriting it using positive exponents and then rewriting it with radicals is because if you plug in 8, unless you can already visualize what that rational exponent does, it's harder to find that value. So I would rewrite this using my positive exponents. So this is 2 over 3 x to the 1/3 minus 2, and then further rewrite this using the radical, which would be 2 over 3 cube root of x, then minus 2. So now we're ready to plug in my x is equal to 8. So f prime of 8 is going to equal to 2 over 3, and then the cube root of 8 minus 2. Now we've already figured out that the cube root of 8 is 2. That's what we did here. So over here we have 2 over 3 times 2, which is 6, minus 2. 2 over 6 can be simplified to 1/3 minus 2. Now this I can subtract. So I'm going to put this over 1 and find the common denominator, which is 3. So we're going to do 1/3 minus 6 over 3. And 1/3 minus 6 over 3 is negative 5 over 3. So this is my slope. So now when we're writing the equation of the tangent line, we have everything we need. It would be y minus negative 12, so y plus 12 is going to equal to negative 5 over 3, my slope, times x minus 8. Now for this next one, we have g of x is equal to 1 over x squared minus 4 cosine x, and we want to find the equation of the tangent line when x is equal to pi over 3. So first we're going to go ahead and find that point of tangency. So we want to know what is g of pi over 3. So we're going to plug it in. This is going to equal to 1 over pi over 3 squared minus 4 cosine of pi over 3. Now, this 1 over pi over 3 squared, let's rewrite that. When you're squaring a fraction, you square the numerator and you square the denominator. So pi squared is pi squared over 3 squared, which is 9. And this is under 1. Minus 4 times the cosine of pi over 3, which if you look at your unit circle, the cosine of pi over 3 is 1/2. So let's clean this up a little bit. 1 over pi squared over 9, that doesn't look very nice. So what this means is that it's the reciprocal of what's in the denominator. Or if you think about it like as if you're dividing 1 by a fraction, then we copy, change, flip, or keep, change, flip. So we're going to keep the 1, change to multiplication, and flip, which is 9 over pi squared. Minus 4 times 1/2, which is 2. So this equals to 9 over pi squared minus 2. Now this I don't expect you to actually combine, because here in the denominator we have pi squared. It's not going to look any better versus if you have a fraction like 1/2 plus 1/5, that you can combine because your answer would be one fraction. Versus this, it would be a much more complicated fraction that you won't be able to combine anyway. So we're just going to leave this as it is. So my point of tangency, which I'll write it here just so that we don't get confused with all of that work, would be pi over 3, comma, 9 over pi squared minus 2. Now let's get our derivative. Before I could take that derivative, we need to rewrite this so that we don't have any fractions. So g of x is equal to, now this 1 over x squared, I can bring the x squared up, and this would be x to the negative 2 minus 4 cosine x. Now I can take that derivative. So g prime of x is going to equal to negative 2x to the negative 3. And the derivative of cosine is negative sine. And then remember that this number just tags along. So negative sine times negative 4 would be a positive 4 sine x. Now I'm going to rewrite this using only positive exponents. So this is going to be negative 2 over x to the third plus 4 sine x. Now I can go ahead and plug in my x value. So g prime of pi over 3 is going to equal to negative 2 over pi over 3 cubed plus 4 times the sine of pi over 3. Now this, we can clean that up. This is negative 2 over, remember, apply the exponent to numerator and the denominator, which would be pi to the third over 3 to the third, which is 3 times 3, 9, times 3, 27, plus 4. And then the sine of pi over 3 is the square root of 3 over 2. Now again, this doesn't look very nice, so let's try to clean this up as much as possible. Negative 2 over pi cubed over 27, we can do the same thing that we did earlier here, which is keep, change, flip. So we keep the negative 2, we change to multiplication, and we flip. So 27 over pi to the third. Plus, now I can do 4 divided by 2, which is 2, and keep the square root of 3. Again, I can further clean this up. Negative 2 times 27 is equal to negative 54 over pi cubed plus 2 square root of 3. This is my derivative, and I'm not going to try to clean this up anymore. I've done as much as I can. So now let's go ahead and write the equation of that tangent line. We have y minus the y value, which is all of this. So I'm going to make sure to put that in parentheses because that is the entire value of the y. So 9 over pi squared minus 2 is equal to my slope, which is the negative 54 over pi to the third plus 2 square root of 3 times x minus my x value, which is pi over 3. So this would be the equation of my tangent line. It doesn't look very nice, but that would be my answer. So now let's revisit how to find when a function will have a horizontal tangent line. As a reminder, when you have a horizontal tangent, that means that the slope of the tangent line is 0, because all horizontal lines have a slope of 0. So that means that f prime of x would equal to 0, because remember, the derivative represents the slope of the tangent line. And if the tangent line is horizontal, then the slope is 0. So I have some steps here on how to find when a function will have a horizontal tangent. The first step is to find the derivative of the function. Then you're going to get that derivative and you're going to set it equal to 0, and then you're going to solve for x. So notice this line of questioning here. It says, when will the following functions have a horizontal tangent line? If you see this word when, that means that we're looking for the x value. X value gives you the location. So if you're saying like, when is that going to happen? You're looking for the x. So here's my function. F of x is equal to 1/3 x to the third plus 3x squared minus 16x. Luckily for us, we don't have to rewrite this function at all. It's already in polynomial type form. So we're going to find the derivative. We take the 3 and we multiply it with 1/3, which will cancel. So that's just 1. So x squared plus 6x minus 16. Now I got my derivative, I make it equal to 0 so that I can solve for x. If you notice, the derivative is a quadratic. And if it's a quadratic, we can solve this by factoring. So we're looking for the two numbers that would multiply to give me negative 16 and add to give me 6. Those two numbers would be positive 8 and negative 2. And then I solve for x. This means that I have 2 points where I have a horizontal tangent line, which would be at x is equal to negative 8 and at x is equal to 2. So remember, when you have your factors, how I got these numbers is you set each individual factor equal to 0 and solve for x. So I'd have to subtract the 8, which is why it's negative 8, and then I would have to add the 2, which is why it's positive 2. Now let's look at this next one. We have f of x is equal to the square root of 2 theta plus 2 sine theta, and we want to figure out where there's a horizontal tangent on the interval 0 to 2 pi. Now you're given this interval because trigonometric functions go on forever and ever and ever. So if you're ever solving for an angle, such as we are going to be solving for, it's difficult when you don't have a particular interval to solve for. Otherwise, your list would go on forever and ever. So if it's from 0 to 2 pi, that means that we're only looking at one revolution on the unit circle. And again, I'll clarify this once we get to that part of this problem. So the first thing that we're going to do is find the derivative. So f prime of x is equal to, now we have the square root of 2 times theta, right? Theta is not inside of the square root. So the square root of 2, that's just the coefficient. It represents, 1 point something, something, something. So we're not going to rewrite this at all. Remember, if you have, for example, the derivative of 3x, how it's just 3, it's the same thing here. The derivative of the square root of 2 theta would be the square root of 2. The theta would just disappear. Then the derivative of sine is cosine, and again, that 2 just tags along, so it will be plus 2 cosine theta. This is my derivative. So now we take this derivative and we make it equal to 0. And now what I want to do is I want to solve for theta. So we got to isolate the cosine theta first. So we start this off by subtracting the square root of 2 to both sides. And I get 2 cosine theta is equal to negative square root of 2. Then I would divide the 2. So we get cosine theta is equal to negative square root of 2 over 2. Now in order to separate cosine and theta, because I want to get theta by itself, we have to apply the inverse of cosine to both sides. So I'm going to take this and I'm going to apply the inverse cosine, so this will cancel here. And I have to do the same thing on this side, apply the inverse. So theta is going to equal to the inverse cosine of the negative square root of 2 over 2. In order to figure out what this means that I'm looking for the angle that would give me a cosine of negative square root of 2 over 2. If you look at your unit circle, we're looking for, again, the angle when we have a cosine of negative square root of 2 over 2. Here is the negative square root of 2 over 2, which is the angle 3 pi over 4. And normally with trig functions, you have 2 answers. So I scan again to see if there's another negative square root of 2 over 2, which is right here, and that's for the angle 5 pi over 4. So my 2 answers are going to be 3 pi over 4 and 5 pi over 4. And that's when f of x is going to have a horizontal tangent. And also I just realized this should actually be f of theta since my variable is theta and not x. And that's using the power rule, using rational exponents and finding horizontal tangents.